All right, Unit 6. Here's your notes packet. It's green. Today we're going to be going over special right triangles. 30 degree, 60 degree, 90 degree special right triangles, and 45 degree, 90 special right triangles. The reason why these triangles are special is because each one follows a distinct pattern. Okay? They each follow a distinct pattern. And I'm going to show you what the pattern is, and then I'm going to show you how to apply the pattern to each one of the two special right triangles. Let's go ahead and start with the 30, 60, 90 triangle. Okay, so a 30, 60, 90 triangle can be turned in any direction that you want it to, but I'm going to draw it so that it is orientated this way. Since it has a 90 degree angle in it, we're going to mark the right angle as 90 degrees, and then the other two angles are 30 degrees and 60 degrees. Okay, now when you have a 30, 60, 90 triangle, there will always be one of the sides will be shorter than the other side. They'll be distinctly drawn that way, where there's one side shorter than the other side. The shorter side is always the side that is connected by the 60 degree and the 90 degree angle. Okay, and then the longer of the two sides, and we're not talking about the hypotenuse here, the longer of the other two sides is always the side that's connected by the 90 degree angle and the 30 degree angle. Okay, so keep that in mind. There's an easy way to distinguish which side is the shorter side and which side is the longer side, and that's by where the angles are put. The shorter of the two sides is always the side connected by the 90 degree with the 60 degree angle, and then the longer of the two sides is always the side that's connected with the 90 degree and the 30 degree angle. Now, when you have a 30, 60, 90 triangle, you're always going to put a 2 at the hypotenuse. The shorter side, you're always going to put a 1. And then the longer side, you're always going to put a square root with a 3. Okay, so that is the pattern that when I said that each of these triangles follows a distinct pattern, the 30, 60, 90 triangle, this is the distinct pattern that this triangle follows. Okay, now the 45, 45, 90 triangle is actually a little bit easier to distinguish the pattern. It's a different pattern than the 30, 60, 90, as that would make sense because it's a different triangle. Because it has a 90 degree angle in it, we're going to mark the right angle with the 90 degree mark. And then the other two angles are 45 degrees. Okay, now in a 45, 45, 90 triangle, the two sides that are not the hypotenuse, they're always going to be the same. And the pattern that a 45, 45, 90 triangle follows is the two sides that are not the hypotenuse, you put a 1 on both of them. And on the hypotenuse, you put a square root with a 2, square root 2. Okay, so these two triangles right here are what we are going to refer to as our reference triangles. Okay, and what we're going to do is we're always going to use these reference triangles to help us set up proportions, to help us solve for missing sides of some given triangles. So what we're going to do is we're going to go over a few examples here. And in the examples that I'm showing you, we are going to be working with a 30, 60, 90 triangle first. So let's call this example number 1. And let's say that in this 30, 60, 90 triangle, I tell you that, and let me put in the angles here. Okay, now, I'm just going to pause here for a second. Okay, many times when you have a 30, 60, 90 triangle, one of the three angles won't be written. So you could see down here in this bottom right angle where I have that mark right there, that angle I did not put 60 degrees in, but we could be 100% convinced that that angle that doesn't have any measurement in it, it absolutely has to be 60 degrees. And the reason is because the three angles in a triangle always add up to 180. And 90 plus 30 is 120. So that means that that missing angle has to be 60, okay? So just be aware of that many examples that you're going to do today and in the future is when you have a 30, 60, 90 triangle, you'll only be given two of the three angles, okay? Now, let's say that I have an X right there on that triangle, and then down here I have a 7. And I want to figure out what's the value of X in this triangle, okay? So here's how we go about doing this. Because this triangle is a 30, 60, 90 triangle, my first step is I'm going to take my reference triangle and I'm going to draw my reference triangle right next to the given triangle, okay? And when I draw my reference triangle, I'm just taking this triangle up here and I'm just going to copy it down here, right next to my given triangle. And I'm going to put in the angles. Notice that I put the angles in the same spot that my given triangle is in. And I wrote a 60 here. And then I'm going to put the 1, the 2, and the square root of 3 in my reference triangle, okay? So this is always going to be your first step. When you recognize you're doing a problem that is either a 30, 60, 90 or a 45, 45, 90 triangle, your first step will always be draw the reference triangle with the patterned numbers in the reference triangle right next to the given triangle. Okay, then what you're going to do next is you are going to write two fractions comparing the given triangle with the reference triangle. And the reason why you're going to write fractions is because these two triangles, because they have the exact same angles, they are similar to one another. So you could see that in the given triangle, the side where the 7 is on, it corresponds with the side that the 1 is on. So I'm going to write that fraction, 7 over 1. Okay, I have to write two fractions. And then you can see that going back to the given triangle, the side where the X is on, it corresponds with the reference triangle, the side that has the 2. So that's going to create the fraction X over 2. Okay, and then so what you do is that after you draw the reference triangle, you're going to create two fractions, always two fractions. And the fractions are going to be created by what corresponds with what? From the given triangle to the reference triangle. Now, what we do is after you've created the two fractions, you're going to multiply, you're going to cross multiply, and you're going to solve to find the missing side, which in this case is X. So I'm going to multiply the 7 with the 2. That, of course, is 14. And then I'm going to multiply the 1 with the X. And 1 multiplied with X is, of course, 1x, and we could just write that as X. And then remember, when you cross multiply, the results are always equal to each other. So this tells us that in this particular triangle, my X value of my given triangle is going to be 14. Okay, so that would be an example of example number 1. We're going to do another one of a 30, 60, 90 triangle. Now, one thing that you have to be careful about is that when you're dealing with either one of these special triangles, they're not always drawn in the same orientation that your reference triangle and your notes are set up as. So for instance, let's say I have this triangle here, where I have the 60 degrees right here, and then I have a 90 degrees. Now remember, all three of the angles won't be given to you, but we know as a fact that this bottom left angle here, it has to be 30, because 30 plus 60 is 90, and 90 plus that 90 is 180. So this is indeed a 30, 60, 90 triangle, okay? And let's say in this case that I'm going to use a different variable. I'm going to go ahead and use G, okay? And let's say that in this given triangle, that bottom side is labeled with G. And then this hypotenuse is labeled with the number 12. Okay, and what I want to do is I want to find the value of G in this example here. So what I'm going to do is I'm going to go to my reference triangles, and this is a 30, 60, 90 triangle, and I'm going to redraw my reference triangle right next to my given triangle. But the key is when I redraw my reference triangle, I have to turn it and orientate it the same way that my given triangle is orientated. And what I mean by that is when I draw my reference triangle, I need my angles in the same spot. So I need my 90 where the 90 is in the given triangle. I need my 60 where the 60 is in the given triangle. Then, of course, that other angle would be 30, and that's going to match up with where the 30 is in the given triangle, even though there's not a 30. We know it's 30. And then in my reference triangle, I'm going to fill in the 1, the 2, and the square root of 3. And you got to be careful because you have to put those special numbers in your reference triangle in the right spot. So the hypotenuse is always 2. So that the 2 is going to go on the hypotenuse. And then remember the leg that is connected with the 90 degree and the 60 degree, that's always going to be where the 1 goes. So where the 90 and the 60 is, that'd be that vertical side there. That's where the 1 goes. And then the other side is going to be where the square root of 3 goes. Okay, so be careful when if your given triangle is orientated differently than what your notes have your reference triangle as. When you redraw your reference triangle, you have to turn your reference triangle so that it's orientated the same as the given triangle. Now, what we're going to do is we are going to match up sides, and we're going to create 2 fractions. Let's start with G. You can see that G corresponds with the square root of 3 side. So what that does is that creates the fraction for me, G over square root 3. Now, don't get freaked out by that square root of 3. It's just a number. It's a decimal, but it's just a number. But we're going to write it as the square root of 3. And then we need to write a second fraction right here. And so we're going to go back to the given triangle, and we're going to go to 12. And you can see that 12 corresponds with 2. So my second fraction is going to be the fraction 12 from the given triangle over 2 from the reference triangle, okay? So you can see that in this particular problem, that 1 in the reference triangle is irrelevant to me. And the reason why 1 is irrelevant is because there's nothing on the side that corresponds with 1 in the given triangle. Okay, so what I do is I cross multiply. Once I write my 2 fractions, I cross multiply. So I'm going to multiply the G with the 2. G multiplying with 2, well, that's 2G. And then I'm going to multiply the 12 with the square root of 3. Okay, so I'm going to multiply the 12 with the square root of 3. And this is where you're going to need a calculator to figure out what is 12 multiplied with the square root of 3 equal to. Okay, so I'm going to just quickly open up the internet here. I'm going to go to desmos.com. Great website to use. I'm going to go to my math tools, my scientific calculator, and I'm going to multiply 12 times the square root 3. So 12 and then the square root 3. And when you write, so this right here, this 12 and square root of 3, that means 12 times the square root of 3. You can see the answer is a really long decimal, 20.78460969. You should try this on your calculator. 12 times the square root of 3. You should type that into your calculator right now. Make sure you know how to type it into your calculator because you got to know how to format a calculator to tell it to do what you want it to do. And you should get that answer right there. All right, Jack, go ahead and do it. Cash, go ahead. Wake up, Cash. Go ahead. Work it out. Sandoval, Santos, Daisy, you should be working this out right now. You should get that. Now, I'm obviously not going to write that entire decimal down. I'm just going to round it to the 10th. So the 7 I'm going to round, so this is going to round to 20.8. Okay, so 12 with the multiplied with square root of 3 is equal to 20.8. 8. Now, my results are equal to each other when I cross multiply, and then I would continue to solve. I would now use algebra to solve, and I would divide both sides by 2. 20.8 divided by 2 is 10.4, and that's what G is going to be equal to. Okay, so in this particular example, the variable, the missing side, which I labeled as G, is going to be equal to 10.4. Okay, now I will tell you that there are some math teachers that will, they'll tell you that they don't want a decimal as an answer. So if you said the answer was, and watch this, if you just wrote 12 with the square root of 3, instead of multiplying it out, and you said that was equal to 2G, and then if you divided by 2, and since 2 is a normal number and not a square root number, I can only divide the 2 into the 12. This would mean that G is equal to, 12 divided by 2 is 6, 6 square root 3. If you wrote the answer like that, without the decimal, I would accept that as an answer, okay? I actually had a teacher once in college that never let us put decimals for answers. So when we were doing these special right triangles, we always had to express our answer like that. We never multiplied it out. That's an option for you if you want to do it, okay? Let's go on to example number 3. And in example number 3, let's take a look at what happens if you're dealing with a 45, 45, 90 right triangle instead of a 30, 60, 90 right triangle. So here's my given triangle. Notice that in this given triangle, one of the 3 angles I did not mark, but we know for a fact because one angle is 90 and the other angle is 45. 90 plus 45 is 135, and then 135 minus 180 means for a fact this angle up here that doesn't have a measurement, it has to be 45 degrees. Okay, so, but like I said, in many of the examples, only 2 of the 3 angles will be marked. Now, for this example right here, let's go ahead and put this bottom side as having a length of 8, and then let's put the variable W on the vertical side. And we're going to find the value of W in this case, okay? So what we have to do is, our first step is next to this given triangle, we're going to draw our reference triangle. And since we're dealing with a 45, 45, 90 triangle, I'm going to draw my 45, 45, 90, put the angles, the 90 degrees in the same spot, the 45 is in the same spot, and then I'm going to put the special numbers in my reference triangle, which are 1, 1, square root of 2. Square root of 2 always being on the hypotenuse side, and the other 2 sides being a 1 and a 1. Okay, so I'm going to label this reference triangle with a 1, and a square root of 2, and then now the process is I'm going to write 2 fractions, and then I'm going to cross multiply to find my missing side, which in this case is W. Okay, so you can see, let's go ahead and start with W. Let's write our first fraction. W corresponds with 1, that 1 right there, in the reference triangle, so that creates my fraction W over 1. That's one of my 2 fractions. I go back to my original triangle. I'm going to go with 8. I can't go with the hypotenuse side of my original triangle because there's nothing there. And you can see that 8 corresponds with 1 in the reference triangle. So that creates my second fraction, which is the fraction 8 over 1. Okay, once I create my 2 fractions, I cross multiply, and then if needed, I use algebra. So I'm going to multiply the W with the 1. That, of course, is just W. And then I'm going to multiply the 8 with the 1. And that, of course, is just 8. So, and then I'm done. That's my answer. So the results are equal to each other, so there's no more solving in this problem. So in this case, my variable W has to be 8. Okay, now let's go ahead and let's stay with the same problem here, and go back to the original triangle, and along the hypotenuse, I'm going to put a, I'm going to put a number here. or variable, I'm sorry. So let's go with another variable. Let's go with the variable y. And what we're going to do now is we're going to use the same triangle and the same reference triangles to now find the variable y, okay? So you can see that y in the given triangle corresponds with the square root of 2. So that's going to create a fraction y over square root 2. And once again, I need two fractions. Now, I already have my second fraction created. It's one of the two fractions from my previous problem, and I'm going to use the 8 over 1 fraction. I don't want to use a fraction that has a variable in it because I already have a variable. So I'm going to use the 8 over 1 fraction from my previous two fractions, okay? And then once I set up my two fractions, I cross multiply, and then I solve. So I'm going to multiply the 1 with the y. That, of course, is equal to y. And then I'm going to multiply the 8 with the square root of 2. Okay, 8 with the square root of 2. And this is where you're going to need a calculator, because remember, the square root of 2, don't get freaked out by that. It's just a number. It's a decimal. So I go to my calculator and I multiply 8 with square root of 2. And you're going to get a really long decimal if you do this. Go ahead and do this right now. Zoe Adams, go ahead, type that into your calculator. 8 times the square root of 2. Isaiah, go ahead and do it. It's okay. It's good. Alondra, I like how you're doing it right now. 8 with square root of 2, you see I get 11.3137085. Okay, now I'm going to round my answer to the 10th, so 11.3. The 1 does not change to 3. So 11.3 is what 8 times with the square root of 2 is, okay? And that is your answer for y. Okay, now once again, if you want to, and I would accept this as an answer, if you just said, Mr. Trutna, the answer is 8 with the square root of 2, just like that, you just push those two things together and you said that was your answer for y, I would accept that as an answer, okay? So if when you're multiplying these out and you have the square roots, if you want to multiply them out and give your answer as a decimal, I'm good. Or if you want to just not multiply it out and just write it out, then I will accept that as well. Okay, so there we go. There is your first notes from Unit 6, Special Right Triangles.